Hello! In the first part of this interactional video series, we learned how Vaadin helps us to control browser web components from server side. Instead of developing the page client side in JavaScript, we use web components and combine them server side. Now let's dive into the database level. We will examine the beverage body sample project which was taken from Vaadin 10 page, and I've converted it to Vaadin-on-Kotlin application. So this is the beverage body, Vaadin original version, which is done in Java and built by Maven. So it's on GitHub, so you can download it and run it for yourself. Just run Maven jetty run, and it should run for you. So I've opened this beverage body sample application in the Vaadin-on-Kotlin project. It's actually directly in the Vaadin-on-Kotlin project as a Voc example flow SQL2o, so a bit cryptic name. So it's located in here. So just clone this GitHub repository, and you should find it here. Yeah, it's here. So it's standard Kotlin and Gradle project, so it's really easy to it's a Word project, so it's really easy to launch in a Tomcat. So local Tomcat, and we will mark the flow SQL2o exploded Word file for deployment. And yeah, let's try to run it. So the project is really a simple project which allows us to edit a list of categories and reviews of beverages. So there is a beer category, cider category, wine, and so on and so on. So this is the reviews list and the category list. So a soft drink, dairy, and so on and so on. So really basic CRUD application which edits a list of categories and list of reviews of particular beverage. The original beverage body application in Vaadin, it just uses an in-memory sample data, but I've converted this application to actually use a real database. Currently it uses an embedded H2 database, but it should be fairly easy to convert to any kind of a database. So in Java world, one typically uses Spring or J2EE and does either Spring Data or JPA to access the database and have transactions. However, they both are built on top of dependency injection and require dependency injection in order to work, which requires you to wrap every tiniest database access behind the service or inside of an enterprise bean, which is quite an overkill for, really something small, like a querying account of categories or something. Even worse, lots of complaints and open questions on Stack Overflow suggest that JPA to be very complex for newbies and actually for veterans as well. As Martin Fowler says in his blog post on ORM hate, JPA is a complex simply because the problem of bidirectional object-oriented mapping itself is very complex. In a nutshell, JPA synchronizes the state between the database and in-memory beans, and JPA tries hard to hide this synchronization from you and strives to do it transparently behind the scenes, but this approach leaks in several ways. For example, JPA entity says JPA specification says that entities are just POJOs, but that's not entirely true, because in order to keep the state in sync, it needs to intercept calls to entity setters. So for example, entity manager.merge function actually extends the entity object dynamically, overrides all setters, uses lazy load collections, adds a bunch of private proxy fields, and returns this extended class. So calling list methods will typically fail with detached exceptions, and thus developers are hesitant to pass these classes around in their applications and instead wrap them in DTOs, so that this class doesn't leave the transactional context, the entity class, that is. Entity manager, instead of hiding the synchronization details, it leaks it in a form of entities being attached or detached from persistence context, and letting the developer kind of remember whether it's attached or detached, and introduce methods to attach, detach, refresh entities, and others which are hard to use properly. And also, you need to specify lazy or eager fetching not only when running queries, where it makes more sense, but also when defining entities. However, at that point, it's not often enough clear how exactly the entity is going to be used and whether it's the eager or lazy fetching should be actually used. Well, both has drawbacks. Eager fetching may load half of your database into memory. Lazy may produce the hibernated touch exceptions. So pick your poison. Since JPA leaks the synchronization details, user must be aware of all that complexity, which is ridiculous when all I need is to add a stupid row into a database, right? So maybe I don't need all of this power. So let's just step back and rethink what we actually really need here. We definitely don't need all the complexity JPA introduces. We can just stop trying to hide the database behind countless abstractions and make the database the source of truth again. Then we can slowly start adding a couple of helpful methods to work around the verbosity of JDBC, maybe add a very simple entity mapping to help with the CRUD operations. So that, for example, deleting a country will actually produce just a delete SQL statement for us, so no need for us to write it manually. We also need a mechanism to start a transaction and commit it afterwards, but we certainly don't need a dependency injection for that. Instead, we can use Kotlin language features to help us here. So instead of running methods in transactions, we will run blocks. So in here we have a category.delete method which deletes the category itself and actually updates all reviews that are linked to this category to kind of null the category so that the foreign constraint is satisfied. In order to run this in one transaction, we can just simply start transaction and commit it afterwards or roll back when there is some kind of exception, but this is really tedious to write again and again. So typically in dependency injection we create a service annotated with transactional, and the container will take care of transactions for us, but it will introduce dependency injection, which is not what we want, right? So maybe we could just write a simple, really simple method which takes a block as a parameter and just starts and stops the transaction around that block. And that's exactly what's happening in Vaadin-on-Kotlin. It introduces a really simple DB method which basically, if there is an ongoing transaction, then do nothing, just run the block. Otherwise, pull a Hikari CP for a database. So we have for database connections. So the connections are pulled actually, and wrap it in SQL2o, which we will use for a really simple object mapping. Yeah, and so begin the transaction, run the block, then commit or roll back, and clean up after the transaction is done. So that's it. That's all. Actually, this method is really simple. You can call it from anywhere. You can call it from background threads, from anywhere and anytime. So you don't need to worry anymore about some kind of persistence context or whatever. Yeah. In order to actually create database tables for those categories and reviews, we simply use the Flyway framework, library, which simply runs these SQL scripts in the order they are defined. So please consult Flyway homepage for more information on how it is precisely being used. I'm using it really in a really simple way. I just define a sort of context listener which runs before the WAR file is actually launched. So I just configure the data source with the H2 in-memory database, then do some initialization, then do the Flyway migration, and then I'll create really simple testing data. So yeah, so I have a list of beverages, right? So nothing special. It's just a map populated by a list of beverages and their categories. And from that, I will take the category list, and for every I create a category object and then hit save. So we already agreed that we will just wrap JDBC with nice API to remote upload. Also, if we introduce utility methods, they must only immediately call SQL statements to run, nothing more. So no cache, no synchronization of objects, no complexity, just selects and inserts, updates and deletes, and that's it. So really simple wrapper around a database. One of such wrappers is the SQL2O library, which we are going to use. What the SQL2O does is that it maps the result of an SQL select into a Java class simply by calling appropriate setters for every column selected. So if a select selects a country name, for example, SQL2O will call the set country name setter on an object, and that's it. So it won't cache anything, it won't create lazy collections or whatever, it will just set country name and that's it. It will just create the object by using 0R constructor, call setters, and that's it. Yeah, so it won't enhance the object, extend it dynamically, it won't eject lazily list interfaces. So when doing CRUD and saving an entity, the project is actually reversed. So the save method should just run the insert into the SQL command. So where should the save method be present? Well, typically it's present in some kind of a DAO service which persists JPA entities, but now we don't have JPA, right? So I guess that the most obvious place to save a category is to have a save method on a category itself, right? So how about having a interface entity? Yeah, it should be entity. It's L entity because of workaround of a bug around flowback. So the entity which has an ID and actually can save itself and delete itself. And by save, I mean that it will just fetch all fields which are going to be persisted. So really simple bean examination, like get a list of all getters, excluding the ID. I expect it to be auto-generated by the database, and generate an insert into SQL statement with the populated values. So nothing more. If the ID is already present, then we are not creating, we are updating, so issue an update statement instead. So, and delete, it's even more simpler. Just delete from our database table name, which is the name of an entity, where ID is ID. So yeah, that's it. So this is kind of a mixing interface which actually brings functionality to an object. So all we need to do to have a save method on a category, we just need to implement this interface, this L entity interface on a category or on whichever object we choose. That will bring the save and delete method in. Yeah. So thanks to the simplicity of just to be able to call the DB method from anywhere, even from a background end or from a REST provider. Yeah, actually, let's look at the REST provider. So we include REST in our application, really simple. Just add a dependency on REST easy, and have this special class application config, which maps all REST services into this /REST. So, for example, and then we'll define this class, which will simply fetch things for us. So this is actually get all categories, so it will just fetch a list of categories and automatically convert it to JSON. And we can kind of implement a simple find all method, which just calls DB, because we can call it from anywhere, right? And just kind of like select all from the table itself. So really easy, really easy to test actually. So yeah, and there we have it. So the list of categories. So since we don't need any entity manager to be injected, that we don't need to create any service and finder classes for every bean and inject them to every Vaadin component or to the REST service, and ultimately having to convert every Vaadin component as a Spring managed bean only to have a bloody database transactions. Not anymore. Also, the category class is really just a POJO, so no dark magic of JPA, change tracking, silent subclassing, lazy one-to-many relations, and then thus 1 + n problem. So how about joins? Well, SQL2o can use any bean. It doesn't have to be an entity. So all that's really needed is just to create a new object, a bean with proper getters and setters, which will hold the result of that particular select. And it's really easy to create beans with Kotlin, because it's just writing in class and listing those properties in here, so one-liner, right? However, there are even easier cases, but first let's look at the finders. So typically finders are also present in this DAO service bean, which finds all reviews based on something. But maybe how about having those finders as a class or static methods on top of review, because that's kind of a most natural place to look for them, right? We are kind of fetching the list or the review instances after all, so it makes sense to have it as some kind of a factory method on the review class. So this find all maybe would be quite handy, at least for example, for the REST web services, and so on and so on. Of course, implementing them on every class is really tedious, right? So maybe there is another way, and actually there is, because in Kotlin we have this companion object which actually takes place instead of static functions on a class. And this is actually an object, a class itself, so it can implement any kind of interface, right? So let it implement the interface DAO, and we can then attach all kinds of find methods on this DAO. So find all, get by ID, find by ID, and so on and so on. And just by having this companion object of category and resu implementing this DAO interface, we can actually use find by all methods, just like this. So yeah, so all that's needed is just to have this companion object implement DAO category, and that's it. And you can of course introduce your own finders. You can use in these finders, you can use a predefined find by method, which takes some really simple expression language or even native SQL queries directly. So yeah, really simple. So let's go back to the join. Okay, so in In this review list, so we have a review beverage name and a number of times being tested, but we have also a category name. So we need to do a join between reviews and categories. So we kind of need to have an object that will hold this result. So it needs to have all fields of a review and a category name on top of that. Well, we can achieve that really simple by extending the review class and adding the category name, right? And all we then needs to do is to craft a select which will populate all the review fields and the category name field as well. So that's exactly what this find review does. It's a finder, so naturally it's a companion object of a review, so we can actually write review.find reviews, and it will run this select. So select all from reviews and the name from category name. The category name from the category C. So review R, left join category C, and so on and so on. So pretty standard SQL stuff. But with this approach, we can actually write a really simple code like this. So in here we have the reviews list. Reviews list is actually route bound to root, to application root. So this is actually this screen because there is no slash. There is also categories. It's this guy root mapped to categories, right? So in here we have this update list function, which gets called basically when you update the filter. So all it does, it just finds all reviews and then send it to actually to the Polymer template, which then actually handles the list display itself. Well, definitely this is not perfect, since we are fetching all results at once, which will get cumbersome when there will be millions of them. So instead, we should feed the data as a Vaadin data provider, because that provides paging, right, to the Vaadin grid, which is demonstrated in the categories list. So in the categories list, we have a grid. So let's check the categories list first. So the search, and the grid itself. So the search, so note how DSL allows us to nest Vaadin components inside themselves or inside one another, and thus the structure of the page kind of becomes obvious in the source code as well. So we have a grid, and we need to set a data source in there. So this is what this update view method handles for us. So since we know how to fetch data for a bean, we also know how to craft a data provider for a bean. So it's really simple. So we will just add a data provider field to every DAO. And thus every entity will have a data provider, which will just construct this special class entity data provider, which just implements the Vaadin data provider and makes sure that all filters and all order criteria are held. But ultimately, all that it does is that it will construct a select, which will actually then map or contain all columns necessary for us to be able to map it to a desired class. So it's really easy to use. We'll just get the data provider. If there is a search field, then we will do a filtering. So we will add a persistent filter to the data source and create a new data source which has this persistent filter always on. So category name like search field value, and just set the data provider to the grid. The grid will automatically poll the data provider for data. It will use the filtering if necessary, and it will display the data in a paged form and highly effective. Okay, so I guess we visited everything there is to Vaadin-on-Kotlin. So the ideas should be clear. So please feel free to start either from one of these four example applications, or you can just start from this Voc Hello World application. Unfortunately, this one still uses Vaadin 8, so it doesn't use Vaadin 10. And this is kind of archetype which allows you to start afresh with a really simple set of files. To actually build a full-blown blogging application, you can just follow the tutorials present on vaadin-on-kotlin.eu page. So this one. So it's a tutorial which will guide you through a running of the project, explain all files and the directory structure, how to run it, how to develop it, how to add new views, and so on and so on. Okay, thanks for watching. That's all I got. Thanks again. Bye.